Okay, here are the three equations from the first question, and we're looking to see how many solutions exist. So it's too hard. In Year 12 methods, we don't learn how to do 3 by 3 matrices. So we need to simplify this down to just 2 equations. So to do that, we have to use that strategy that we used earlier on in a previous question, which is elimination. So we need to pick one of these variables to get rid of. And it doesn't matter which one, but look at this, y, there's 2y here, negative 2y here, so you can already see that's an easy one to get rid of by adding equation 2 with equation 3. So it doesn't matter which one you choose, but let's do that because it's simple, so less likely to make mistakes. Okay, so equation 2 plus equation 3, let's do this. Equation 2, kz, and then the plus 2y, take away 2y, plus x plus 4z, that's all going to be on the left hand side, and then on the right hand side, 1 plus 0, so that's 1. And then here, I've just put k and 4 in the bracket, so if you expand it, you just get the same thing, kz plus 4z, and then plus x equals 1. Okay, so that's part 1 of our elimination, but now we've used equation 2, and we've used equation 3, but it's important when you do elimination or substitution, when you're getting rid of an equation, so getting rid of a variable, going from 3 to 2, you need to use all 3 equations. So we've used 2 and 3, now we need to use 1. And it doesn't matter if you use 1 with 2 or 1 with 3, but we just need to make sure we've used all of them at least once. So we need to get rid of this, the y in equation 1. So negative ky is what we have, so you can see that we can use 3, but it's easier to use 2 because it's positive. So no reason really, but it's just a bit easier, so we'll do that one. So times equation 2 by k on 2. This is because when you times 2y by k on 2, then you're going to get ky, and then ky, take away ky will be 0y, so we'll have eliminated y from these. And that's our goal. So let's do this. Times the whole of equation 2 by k on 2. So we've got ky plus k times k on 2z, which is k squared on 2z. And then equals 1 times k on 2, which is k on 2. Okay, so that's just modifying equation 2. Now we need to add that with equation 1 to eliminate the y. So let's just go through carefully. We've got 4x on the left hand side, 4x plus this, we're adding it to this, k squared on 2z, so 4x plus k2 squared on k squared on 2z, and then the plus ky here, and take away ky here, and then the last, it's got a bit blurry, plus 6z, that's all on the left hand side, and then on the right hand side over here, we've got k on 2 plus 2. So we're just adding this equation here to this equation here, and this equation is a modified version of equation 2, so because of times equation 2 by k on 2. This is all to get rid of y, so we can just have 2 equations. So now we simplify this equation, so just get rid of, so plus ky, take away ky equals 0y, so we don't need to write that anymore, so we've just got 4x plus k squared on 2z plus 6z equals k on 2 plus 2. Now, you can write these in the brackets, so we bring the terms together. 4x plus, in brackets, k squared on 2 plus 6, close brackets, z, so this all times by z, equals k on 2 plus 2. Okay, that's part 1. Now, part 2. So, now, from what we did here, we're left with this equation here, and where's the other one? This equation here. These are the 2 simplified equations that we got from these 3, but now we only have 2 and there's no y, so it's a lot easier to work with. So let's just go over here to our two equations. We'll call them equation A and equation B. It doesn't matter what you call them. This is just to make it a bit easier for ourselves. So we're going to use matrices to do this. This is definitely what I find the easiest. I think you will too. So if you remember how matrices work, so we've just put k plus 4z plus x. I've just written this up here. So k plus 4z plus x. And then here, I wrote it just a slightly different way. But I'm saying this here and this here. That equals this. So this is just so you have to be careful of. You just have to know how matrices work. I'm just saying, since this equals this, then. So we need to know why. Why does this equal this? So you go k plus 4 times z, and then 1 times x. So with matrices, you go here times here, plus here times here. For the top row, which is this. And then for the bottom row, then we go this one times this one, which is here, plus this one times this one, which is here. Okay, so if you don't understand that, just quickly, I can revise matrices with you, but yeah, so you just go here times here, plus here times here, and for the top, and here times here, plus here times here. Okay, so if that equals that, then we can say this, because that, equals the right-hand side. So we're just saying, this is just another way to write out the left-hand side of these equations, and here's the right-hand side. So if this left-hand side equals this thing, then this thing must equal the right-hand side, because the left-hand side equals the right-hand side. Or if you want, you can write it out a different way. Or you can say ax equals b, and then just say this is a, this is b. Sorry, this is a, this is x, and this is b. So that's what I've put here, but that's not as important. You don't have to use that notation. That's just a common notation we use with matrices sometimes. Okay, so now this is the important bit. Determinant of A. So remember, A is this matrix here. Okay, so A is this one and this one. The determinant is AD take away BC. Let's go back quickly and look. So the determinant, this is A, B, C, D. Not here, obviously you can see the different letters and numbers, but in a matrix, any matrix, it's always like this. A, B, C, D. Ooh, that's a bad C. But it might be 2x here and negative y here and 1 here and 3 here, but you still can call it A, B, C, D, okay? So this is A, this is B, this is C, this is D. So the determinant is A times D take away B times C. So k plus 4 times 4, take away k squared on 2, take away 6. Let's quickly have a look. So AD, k plus 4 times 4, all times 4, take away BC. So 1 times k squared on 2 plus 6, which is what we've got here, okay? So then I've just expanded the brackets here. So 4 times k plus 16, take away k squared on 2, take away 6. And then you can just do 16 take away 6 is 10. So let's just simplify. This is the determinant of that matrix A, okay? So now, let the determinant equal 0. So when the determinant equals 0, then there must be either infinite solutions, so it's the same line, or there's no solutions, which means it's a parallel line. So same line is infinite solutions, because if we have this line and this line, they're touching here, they're touching here, they're touching here, 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 everywhere along the line they're touching. And if it's parallel, just pretend that's exactly parallel, then they'll go on forever. They're never going to touch. They'll just go on. Even over here, they'll still be the same, okay? No solutions. So that's, you just have to know, if the determinant equals 0 of this matrix, then there'll either be infinite solutions or there'll be no solutions. So it means the gradient will be the same. But you don't know about the value of C, which moves it up or down. Okay, so let's let the determinant of A equals 0. So what we do, we go 4k plus 10, take away k squared on 2 equals 0. This is here, we're letting the determinant equal 0. And then here, I just doubled it to get rid of the on 2. So negative k squared plus 8k plus 20 equals 0, okay? And now I times it by negative 1, times it all by negative 1, just to get rid of that negative. So k squared, take away 8k, take away 20 equals 0. So just change this negative to positive, this positive to negative, this positive to negative, and this is 0, so it doesn't matter. When you times it by negative 1, it's still going to be 0, okay? So now we have to factorize this. So if you remember how to do it with the cross, we need these two things to add up to negative 20. To times to negative 20, not add up. So negative 10 times 2 equals negative 20. That's right. And then we need them to add to negative 8. So is negative 10 plus 2 negative 8? Yes, it is. So this works. Now we need to see. That's how you factorize. It's kind of guess and check until you got it, but this one's pretty simple to get. So now we can look at that and go k, take away 10 times k plus 2 equals 0, because we let the determinant equal 0. Now this is just a factorized version of the determinant. So therefore, k equals 10 or negative 2 for infinite or no solutions. Now we sub these values of k back into our original equations, okay? So our original equations, the two that we already simplified, we got rid of y from them over here. So we're just putting k back in equation A and k back in equation B, because now we know what it must be. It must be 10 or negative 2 if there are infinite or no solutions. So let's start with k equals 10. This was the equation. Now just say k is 10, so therefore this is 14z plus x equals 1. And for equation B, k is 10 again. So 4x plus k squared on 2 means 100 on 2z. And then over here, k equals 2, so 10 on 2, which goes down to 5. And 5 plus 2 is 7, so that's the right-hand side simplified. And over here, 100 on 2z goes to 50z. And then you can add that to 6z, so you've got 4x plus 56z equals 7. Okay, now we need to see, are these two equations that we've got when k equals 10, are they the same equation? If it was the same equation, like over here, then there's infinite solutions. Okay, let me just turn on the light quickly. Okay. Are they the same equation? Let's just make x the subject of the equation to make sure, to see if they're the same equation or not. So for A, we'll just move z to the other side, the 14z. So x equals negative 14z plus 1. And then for equation B, make x the subject. So for x, move this to the other side, negative 56z plus 7, and then divide everything by 4 to make x the subject on its own. So negative 56 on 4z plus 7 on 4, which equals negative 14z plus 7 on 4. So is this equation here the same as this equation here? They have the same gradient, but the c's are different. So that means 7 on 4 is bigger than 1, so they're both going, say they're like this. The c, which is where it will intercept this axis, this c over here, 7 on 4, that's higher, 7 on 4, and this one is 1. So this one, they're going to be parallel, but they'll never ever join because this one's higher, okay? So they're different lines with the same gradient, which means there are no solutions when k equals 10. Okay, now we have to check the other option, which over here we can see k equals 10 or k equals negative 2 for infinite or no solutions. So now we check k equals negative 2, so it's a bit messy. Okay, so over here, sub in k equals negative 2 to equation A. I've already done that. I'll just pull up equation A for you. Okay, k plus 4. So now that's negative 2 plus 4, which is 2. So 2z plus x equals 1. That's the new equation A now that we've subbed in the value of k. And for b, this was the equation for b. Now we sub in the negative 2 for k here and for here also, which means 4x plus 4 on 2 equals 2. So 2z plus 6z, and then on the other side of the equation we've got negative 2 on 2 which equals negative 1 plus 2. So negative 1 plus 2. Now simplify this, add the 2z with the 6z, which is 8z, and add negative 1 and 2, which is 1. So 4x plus 8z equals 1. Now, are these the same lines or different? Let's solve for x again just to confirm. So move 2z to the other side. X equals negative 2z plus 1. That's for equation A. Now for equation B, that says B, we'll put 4x equals negative 8z plus 1. Sorry, it's a bit messy. So I'm just moving this 8z to the other side to make it negative 8z. And now we divide by 4 to get x on its own on the left. So x equals negative 8z divided by 4 is negative 2z. And 1 divided by 4 is quarter. So x equals negative 2z plus a quarter. Now you can see again, same gradient. So as the determinant showed us, they'll either be the same line or parallel lines. So they'll either be infinite solutions or no solutions. But you can see here, the c value is different. 1/4 versus 1. So again, one's going to be higher than the other. They're never going to touch. They're parallel lines. So therefore, no solutions. So if k doesn't equal 2 and k doesn't equal 10, I should say negative 2, sorry. It's a typo. If k doesn't equal negative 2 and k doesn't equal 10, then the solution is unique because the determinant of A will not equal 0. You know this because we worked out over here the determinant of A is only 0 when k equals 10 or k equals negative 2. So therefore when k doesn't equal negative 2 or 10, then the determinant will not be 0, and therefore, you know, there'll be one unique solution. And then if it does equal negative 10 or negative 2 or positive 10, then there'll be no solution because, as we saw here, there'll be parallel lines for both those two values. So what this notation says is when k is an element of real apart from negative 2 or 10, which means when k is anything except those two values, then there'll be a unique solution, one solution. But when k is an element of the set of negative 2 or 10, which means when k is negative 2 or 10, then there'll be no solutions, as we proved here and in the page before. Okay, so that's question 1 done.